Alright students, this sum is just opposite to the previous sum. Okay, in the previous sum what was there is, see, the initial velocity of both the gun and the bullet was same because bullet was inside gun, isn't it? And here you see the final velocity of both the girl and the cart will be same. Okay, this is the sum of girl and cart, and last what's the sum of bullet. Okay, here what happens is the bullet was inside the gun, right? That means the velocity which the gun has, same velocity is the bullet having, but here you see in the final velocity the velocity of gun and velocity of bullet is separate because they are separated from one another, right? But here you see they are separate from one another, means the girl is having a different velocity and the cart is having a different velocity. But now you see here girl is over the cart, that means the velocity which the cart has, same velocity the girl is having. Okay, that is why in first case what we did, we wrote both the mass in common and then we multiplied it with the velocity because both the mass was having same velocity. Okay, and later what we we differentiated this. Okay, we like segregated this, and one mass with another velocity and another mass with another velocity we did. Okay, here is the opposite case. Okay, but here what we are doing in the first case, girl is 5 kg. Okay, and she is having a initial velocity of, she is running with the velocity of 5 meter per second. Okay, and the cart, okay, this cart is of 3 kg and it is stationary. Question has said that thing. Okay, question is saying a girl of 40 kg running with the mass of 5 meter per second, okay, climbed on the cart of 3 kgs with a which was stationary. Okay, that means which has a zero velocity. And now that means the momentum, initial momentum is equal to 200 kg meter per second square. Okay, what is initial momentum? Initial mass into velocity, isn't it? Mass of body 1 into the initial velocity of body 1, mass of body 2 into initial velocity of body 2 is the momentum 1 is equal to p1. all right, and now momentum 2. okay, the second momentum after collision or after after the girl has climbed. Okay, total momentum after the interaction of girl and the cart. You see we are taking it in common because girl is over the cart, the speed this cart has, the girl has the same speed, right? So 40 plus 30 into v, they have a common speed, and now 43v, we are to find out the v. Now according to the law of conservation of momentum, okay, the momentum before interaction, this is equal to the momentum after interaction. Okay, that means 43v, okay, is equal to 200, and the final velocity is equal to 200 by 43, that is plus 4.26. all right, and here we are finding out the goal on the cart will move with the velocity of plus 4.625 meter per second in the direction in which the girl jumped. Okay, that means why we are getting in positive, because here this is the velocity of the girl we are finding. Okay, and in which direction she is jumping, she is also moving in the same direction they are going. Okay, and that is why we are only finding the velocity of the goal, we are not finding the velocity of the cart. Okay, here we are finding the velocity of the gun, we were not finding the velocity of the bullet. If we are finding the velocity of the bullet, okay, it would come in positive, but we are finding the velocity of gun in this case, so we are getting the answer in negative because it is going this side and it is going this side. all right, force is going this side and then the gun is forcing this side, that means this is opposite force. Here girl is moving in this side only and she is going this side again. Okay, this is positive.